In this video, we'll see how to set up a protein file in the Protein Thermal Shift software to analyze protein melting data and determine if any of our various test conditions leads to either an increase or decrease in the stability of our protein or binding of a ligand. But first, if we haven't done so already, we need to download the Protein Thermal Shift software by going to lifetechnologies.com, Technical Resources, Instrument Software Downloads. Here, under the Real-Time PCR section, there's a link for Protein Thermal Shift software. Click there, and follow the on-screen instructions to download and install with a free trial license. Once the software is set up on your computer, double-click the Protein Thermal Shift icon. The home screen appears. At this point, click the button that says Create Study. Enter a unique name for the study. Since the run we'll be using as an example tests different buffer and salt conditions, I'll call this study Protein A _ Buffer and Salt Test. Next, we'll select the real-time instrument model used to run the assay. Over to the left, we'll go to the next menu item down, Conditions. This page allows us to specify the various parameters being tested. Notice that under the Condition Names window, both buffer and salt, our two variables, are already listed, along with a couple of other common options. Now we could also add any custom parameter we want, up to a total of 20 different conditions, by clicking the Add button and typing the name. With protein selected, I can go over to the right and enter the names of the various proteins we're testing. Our experimental plate only contains a single protein, so I'll enter that name here. If I next choose salt, notice what happens to the other window. It allows us to add values for each concentration of salt that we're testing. Since we have 4 different concentrations of sodium chloride, I'll click the Add button 3 times and then change the names in all 4 boxes by selecting and typing. And by the way, if you don't like the idea of having to manually enter all this information, in just a moment I'll show you how to get this same data into the study without having to go through this process. Now, once we're done, we can click on Buffer and do the same thing. We have 4 buffers named A, B, C, and D, so I'll just click the Add button 3 times and I'll enter those names. At the bottom of the page, we see an option for creating analysis groups. By creating individual groups and then assigning wells to each specific group that we create, the software will do a more focused analysis, comparing each well in a single group to a designated reference sample. We're going to skip that option for the purposes of this demo, but just know that the software provides some great options for focusing the analysis more narrowly. Let's go back over to the left and click the next option down, Experiment Files. This window allows us to select which experimental run or runs that we want to add to our study. This is probably a good time to say what exactly Protein Thermal Shift software studies do for us. Well, a study allows us to combine multiple experiments for analysis. We can, if we want, look just at a single file within a study. However, we could also combine 2, 10, even 100 or more runs, effectively creating a very large data set. For researchers doing big screening experiments spread over many plates, studies offer a really big benefit. In our case, we just want to add a single experiment. To do this, I'll click Import, navigate to the location of the file I want to analyze, and import it. So this is actually a full plate of test samples and controls that I ran earlier. Notice though that there are no labels in the wells regarding our specific protein name or test conditions. Well, that's okay. We can add that information in one of several ways. Because we entered both the protein name and the individual salt and buffer conditions a moment ago, we can now add those to the appropriate wells on the plate. One way to do this is simply to select identical wells, and since I ran identical quadruplicates, I'll highlight all 4 wells containing the same thing, and then to click the Assign button. I can now choose the exact parameters of these 4 wells, including salt concentration and buffer. I could also assign the well to be an unknown sample, a reference sample, or a no protein control. So I can then go through this same process across the whole plate. Clearly though, that could take a while. So a faster option would be to use the autofill options in the software. I'll select the wells I just labeled, right-click, and choose Clear so everything disappears. Now I'll select the first 8 columns and assign the protein name, since protein A is in all these wells. Hit the Assign button, then choose Protein A. Next, I'll select just the top 2 rows, since all of these wells contain buffer A. And by the way, after selecting the wells, I can also just right-click and choose Assign Well Content to get that same window, or even do a Control-E, whichever you find easiest. I'll choose buffer A for all of my selected wells. I now want to assign buffer B to the next 2 rows, buffer C to the 2 after that, and buffer D to the final 2. And note that when I go back to conditions and select buffer, that's the order in which my various buffers appear. Very important. I'll now click on Autofill Settings and dock this window. Buffer is set to copy, meaning if I select wells in which buffer is assigned and drag them across adjacent wells, buffer A will simply get copied. Not what I want, so I'll click on the Series button. Now, with the first 2 rows selected, I'll take my mouse down here until I see hash marks. Then I'll drag this whole segment down. And look what happens. The various buffers get added to the appropriate wells. I can do exactly the same thing in columns with my salt concentrations. I'll select column 1 and choose 0 millimolar for salt. I go over to my docked window and choose Series. So when I drag those wells across, my salt concentrations get added as a series, while all other parameters get copied exactly. Because all of my final data will be represented as some sort of change in temperature, we need a starting point to make that comparison. I'm going to designate a reference sample. I'll do that by selecting all 4 wells that contain 0 nanomolar sodium chloride and buffer A. I'll then do a Control-E and change the task to Reference. So you see that these wells are now tagged with an R. And as I mentioned earlier, each analysis group will have its own reference sample. Now in our case, we only have one analysis group, so we only assign one set of replicate wells to be the reference. Finally, since columns 9 through 12 are no protein controls, I'll select them, do a Control-E, and choose NPC as the task. And with that, the plate is labeled. By the way, there is one additional method for entering setup information that allows us to completely skip most of what I've shown so far. It requires filling out an Excel sheet with all of our well-specific information and then importing it into a study. Here's what that sheet would look like for the experiment we just did. We could of course change or delete any of these headings depending upon our experimental variables, or we could even add our own column heading such as pH, all the way up to 20 different conditions if we had that many. Now once we've created and saved our Excel template, we just go back into Protein Thermal Shift software, click on Load Plate Template, navigate to that file, and open it. And one final thing, after you've made any changes like this to your study, hit the Save button. And that's it for setting up a study. In the next and final video of the series, we'll see how to perform a complete analysis of our melting data. I hope you'll come back.